Hello, everybody. Hello and welcome back. We are in Chapter 4, Measures of Central Tendency. Thank you to all of you. All of you did your Lab 0, which included a survey, which we're going to use the data from that survey as we're talking about measures of central tendency. Okay, so now moving right along to slide 2. Here are some definitions. So, measures of central tendency are just statistics that summarize the central or typical value of a set of data. And the three most common are the mean, the median, and the mode. Essentially, they are three ways of describing the average or the most typical, the most common value. A percentile is the point on a scale at or below which a specified percentage of the scores fall. So if you've looked at a lot of test results, and then you know that a student that scores in the 90th percentile has about 90% of students scoring below them on that particular test. 90th percentile is pretty good. A kid who scores at the 50th percentile on a particular test is right in the middle. About half the kids who took the test scored above that child, about half the kids scored below that child. So if you're familiar with looking at these norm reference tests, standardized tests, and the scoring that goes along with it, then percentiles will be familiar to you. Okay, let's start out with the mode. This is slide 3. The mode is the most commonly occurring value. So which value wins? If you look at a list of numbers, usually there's a clear winner. So the mode for that first list of numbers is 1 because there are 4 ones and there's only one of every other number. When two values are adjacent, the two values that appear the most frequently are adjacent, then we average them. Okay, so if 1 and 2 have the most, were the most frequent values in a particular data set, then the mode would be 1.5. Slide 4. There may be more than one mode, and in fact, when we were talking about displaying data, we talked a little bit about bimodal distributions. So bimodal distributions have 2 distinct modes or peaks. For example, that list of numbers there would be a peak if you were to graph the frequency of 1s, 5s, 7s, and there would be a peak at the frequency of 9s, because there are 3 of both of those. So there are 2 modes there, 1 and 9. Okay, next slide, slide 5. So, quick way to find the mode is to sort your data ascending or descending and look for a value with many instances. So, on the survey that you all filled out in Lab 0, there were 6 questions. And you could indicate, there were 6 questions that were about statistical tasks. So there were 6 statistical tasks that you indicated how anxious they made you feel. And you could indicate whether you had no anxiety about doing that task, whether you had increasing anxiety about doing that task, or whether you had strong anxiety about doing that task. If we were to count how many of you, how many of the questions for each of you, how many of them did you choose strong anxiety, we would have that list that you see right there on this slide. And so what I did was I took, so that variable is strong anxiety, and if you'll probably remember this from, if I did it in the previous video. I can't remember if I did strong anxiety. I think I did. And I sorted it, okay, just from ascending, sorted it ascending, so that's from the lowest value to the highest value. And we see that you had a choice. You could have chosen 0 questions. You could have indicated that 0 of the 6 tasks caused you strong anxiety, all the way up to all 6 of the 6 tasks causing you strong anxiety. Statistics tasks. Okay, say that 5 times quickly. Okay, as you see in that list, most people said that 0 of the 6 tasks caused them strong anxiety. So the modal value was 0. And next slide. If we were to graph those responses with a histogram, we see this histogram on the left. There are 23 students in this class, so N equals 23. This is a histogram of the frequency of strong anxiety scores. Okay, well, basically, I should really call it a bar graph, because technically, a histogram, you usually have intervals at the bottom, right? Let's call this a bar graph. In this bar graph, even though, it does show frequency, in this bar graph, along the x-axis, we have the numbers of items marked as strong, causing strong anxiety, feelings of strong anxiety. Along the y-axis, so remember x across axis, the y-axis is up and down, we have the number of students. And 14 of you, for 0 of the tasks, you indicated that they made you strongly anxious. 5 of you chose 1 task that made you strongly anxious. 2 of you chose 2 tasks, and 2 of you chose 3 tasks. Okay, so we know that the mode was 0 tasks causing strong anxiety. That was the modal value. And on the histogram on the right, you see the percentage of men spending at least 1 hour per week participating in sports or exercise by age. And the group with the highest percentage, the modal group, is the group of men who are aged 16 to 24. They looks like over 60% of them spend at least 1 hour per week participating in sports or exercise. Okay, so that's mode. Slide 7. So in Excel, you can use the mode.molt and with the range of cells in parentheses in order for Excel to give you the mode. If you have non-numeric cells, you have to change it to numeric values. Excel can't count letters or words. And if you have more than 1 mode, you can highlight a range of cells and click on the formula and then hit Control-Shift-Enter. All this is much easier to actually do than to explain. Okay, advantages and disadvantages of the mode. An advantage, it's not influenced by extreme scores. Okay, so we know what was the most common value, and if there's a score way over here or way over there, it's not influenced by extreme scores. It can be used with all data types, including nominal data. Disadvantage, it may not represent a large proportion of the scores, particularly when you have kind of like a flat distribution and you do have a peak, but there are a lot of people who are close to the peak. It's just not the mode. There may be a lot of people who are not represented. Now, for our class, since 14 out of 23 of you, for 0 of the tasks, you chose strong anxiety. For our class, it did represent a large proportion of the scores, over half. Now, another disadvantage in some cases is that it ignores extreme values completely, and you can't really use it to compute any other statistics. Okay, so next slide, slide 9. The median is the central value in an ordered series. Okay, so again, like I was talking about those standardized test scores, and seeing whether or not a certain scale score, what's the percentile that it's associated with. So the median is where it's the 50th percentile. 50% of the scores fall at that value or below. And so you see, if you see a symmetrical bell-shaped curve, the median is usually at the peak, right? In a bell-shaped curve, the symmetrical unimodal non-skewed curve for the distribution of values. But it may not be at the peak in a skewed when the distribution is skewed. So if you've got 25% of values, over here on like a long flattish tail, and the next 25, so you got 25 and 25, and so right there is your median. And then even if you got 25 more and 25 more over here, percent more over here, your median back here, okay? When you have an odd number of scores, it's just the median is just the middle value, the value right in the middle. It's easy. You count what's on, what's the same number on the below and and above. When you have an even number of scores, you take the average of the two center values. So if you had 8 scores and you had 2 as your 4th score and 3 as your 5th score, your median would be 2.5. Okay, slide 11. So, a quick way to find the median in Excel, for example, if we were looking at the year that everyone in our class was born, you could sort them and then highlight to get the total number of cells. If you highlighted the values, I think it shows in the bottom like how many cells you highlighted. We know there are 23 people in this class, so let's see. If with 23 people, then we would have 11 people on one side, 11 people on the other side. That's 22, and that 23rd, that middle person right there. So 11 and 11, that middle person. So our most senior class member was born in 1962. Our most junior or youngest class member was born in 1995. And right in the middle was someone who was born in 1979. The median value for the year born among students in our class is 1979. Okay? Now, so that kind of gives you a sense of what the middle is, right? And then there's the formula, and you would use in Excel for if you wanted Excel to find the median instead of you going count 1, 2, counting down. For example, in our data set, if you did the formula equal sign, median, and then the range would be from D2, because column D had our year born data, to D24, and it would identify that. Okay, so slide 12. Advantages and disadvantages of the median. An advantage, that should say, instead of saying median, it should say advantage. It's not influenced by extreme scores. Again, if there was somebody who was born in 1932, it wouldn't affect. If our most senior member was born in 1932, it wouldn't affect the median, which would still be 1979. It's a reasonable estimate of what most people mean by the center of the distribution. It can be used with ordinal data and other categorical data, not nominal, but ordinal data, okay? So for example, if you wanted to know if people were racing and you had their racing times, and you wanted to know, well, who came in dead center between the fastest person and the slowest person. You want to know which person, not which time, would be the average of the two. You could figure that out, even though there may be differences in the gaps, right? So ordinal data. Okay. Disadvantages, you may not want to ignores extreme values, and also you can't use it in many statistical equations, which brings us to the one that we know the most, that we use the most, the arithmetic mean, or what we're usually talking about when we say average. Now, it's denoted as X bar, or X with a bar over it. Sometimes you see other letters with a bar. You might see an M with a bar over it. And then now I'm gonna throw in a formula, and formulas are why when I tell people that I teach statistics, they kind of go, oh. Okay, so let's demystify every single formula, okay? So, because I don't want you to feel like, if you meet someone who teaches statistics, that you're going to want to go, oh, which is what I got. That happens all the time when I say what I teach, even though I'm excited about it, as you can tell. Okay, so one of the things about these formulas is that a lot of the symbols that are used in mathematical language, and I'm sure you're starting to notice that it is a different language, right? In mathematical language and statistical language, the symbols that are used are Greek letters. So when I took my Foundations of Statistics class, I got sick of seeing Greek letters that I didn't know how to say them. And those of you who are involved in Greek life in college, or maybe your kids are involved in Greek life now, you may be familiar with the names of all of these Greek letters are. I wasn't, so I went to Wikipedia. I printed out the Greek letters just to give myself a cheat sheet, because they are used so often. And so, for example, this over here, that sigma, right? And to make it, we got capital and lowercase, right? So the capital sigma looks like kind of like an E. And then the lowercase sigma looks like that circle. But it can also be written as like this S thing. Okay, so sigma is going to be our symbol for adding, for sum, for finding the sum. Okay, so, my baby is crying. This is the danger of broadcasting from home. Okay, I'll be right back.